So hello students, welcome once again to our YouTube channel. So that's a question for us for today, and see that I will rate this question as a very crisp question, a trick based question. Okay, rather I will say it's a observation based question and a very crisp question. We'll be solving it maybe within seconds. Okay, so how I started this question, I just said okay, let me try to evaluate few factorial and then add them up. Then I observed, and we all know it, okay, from 5 factorial onwards you will have always 0 at the unit place. Okay, so add them 3, add them 9, add them 33, add them 153. Now from here onwards you add any factorial, any number of factorial after 5 factorial. Okay, you will always have 3 at the units place. All of you agree or not, bacho? We will always have 3 at the unit place. Now we are solving it for p square. P is an integer. Now, can you think about an integer whose square has 3 at the unit place? Answer is no. 1 square is 1, 2 square is 4 at the unit place, 3 square is 9 at the unit place, 4 square is 6 at the unit place, 5 square is 5 at the unit place, 6 square is again 6 at the unit place, 7 square is 9 at the unit place, 8 square is 4 at the unit place, 9 square is 1 at the unit place. We don't get 3 at the unit place or any perfect square of an integer. What does that mean? That means you can't go beyond 3 factorial, because after you add 4 factorial to 9, you start getting 3 at the unit place, and that will continue till whichever x you go there. So that simply means that x factorial till, so 1 factorial plus 2 factorial plus 3 factorial, which is 9 p square. So therefore x is nothing but 3, and that's why I said it's a very crisp question here. Okay, so we can solve it if we observe that simple thing. We can solve it within seconds here, bachcho.